all set up already.
Yeah.
You get to see the build process.
Ooh. Okay.
You want to test it? I already
Okay.
tested it. I know
Okay.
it works.
So it works?
Yeah.
So these are the two switches.
So we only have one input switch, and that's on switch 0.
Yeah.
So this right here is the input we change.
And this one doesn't have the clock.
Right? So instead of doing clock, it says use pulse
Yeah.
switch A.
So
we're
just
using
put.
pulse.
So this is on or off.
That's on. Up is on. Down is off.
So which lights
So
changes?
high low. So right now, if it's low, right?
Yeah.
That means we're inputting 0.
Zero.
Q prime is
Yeah.
yeah.
Okay.
So Q is 16. So Q prime is the yellow one,
Okay.
right? So when we flip it, nothing happens until we hit the pulse.
Okay.
And then the light switches. If you look at where the light is,
Okay. Okay.
make sense?
And you eliminated all the issues you had before.
So this is on. This is on right now. So
that
this
is on.
So this is on. Then until you hit the pulse.
Yeah, until you hit the low to high.
And this one is what? Q prime or Q?
Q.
Q. Okay. Okay. Okay.
It's actually one bit.
Okay.
That's how the world works. Fundamentally, like being able to latch one bit.
Okay, that makes sense.
Done. Yeah,
That makes sense.
that's
Okay.
what they did in the 70s.
Yeah.
That makes sense.
Now we can make computers.
Now you can make computers. You just need 8 of them, and you can make the 16.
Okay, so
Last
we're
chapter.
done. So we're done with this.
Yeah,
Yeah.
I mean, this is like
Well,
Oh yeah, we took a picture of the circuit.
yeah. Remember,
Yeah,
most of the time it's troubleshooting the circuit.
I think that was good. That was a good.
Well, I think
Yeah.
it was a
Yeah,
smart
yeah, yeah.
idea to check all the switches.
Sure,
So now we know in the future our
Exactly.
switches will always be good,
Exactly.
unless something goes horribly wrong.
And those are like less used, so they're in better shape. And they,
Yeah. I guess now we also know that our pulse works. So I have a question though. What's the difference between pulse 1, pulse 0?
just
you can-
two separate ones, yeah.
Well,
You
yeah.
can-
Well, you can this column has a
could
one
be
above it.
like one negative to the other, so you can have the pulse at the.
So I put it in
Like a negative
I put it
value.
in 1 at first,
then it's
and it didn't work. So
so now it's at 0.
yeah. So I moved it to 0. So when I had it in
Yeah,
1,
I think the best way is to
what
measure it.
happened,
Yeah.
right, is when I would flip it, it wouldn't wait. It would just
Sure.
go immediately.
Oh, okay. So,
So-
but this is the latch or the flip flop.
This is the latch still.
This is the latch.
Yeah, the latch will change. The latch will change when the clock is
Without-
high.
Okay,
Everything
yeah.
is
So
when
it's
the clock
always
is
high.
Exactly.
Okay, that
It
makes
follows-
sense.
yeah, it
Say that
follows-
again.
So the latch will change when the clock is high. When we
Okay.
have it in
It
pulse
follows.
1, it's always high.
Yeah.
Right. When we have it in 0,
Mm-hmm.
it's low until we hit the pulse button. Then
Okay,
it
so
goes-
that's
it
so
spikes
that's why
high.
we want it at 0, not
Yeah.
at 1. Okay, that makes
Yeah,
sense.
so
Yeah.
the latch will always follow. That was follow.
Okay.
Yeah.
Okay.
Okay.
All right. So we can
This company
proceed.
still exists, RSR Electronics.
I would
That's a good picture.
keep hopes too high about that.
Yeah, I took a picture of it, so we're good.
Did we have the truth table filled out? 'Cause I can't edit. I don't have Word on my computer.
Yeah,
Like,
we-
I can. No, I can't.
I can. Yeah, we can edit.
Yeah.
Why can't you edit it?
Well, because I don't have Word downloaded on my computer.
Oh,
It
okay.
wouldn't let me. So I have like Office, but when I download documents, it downloads like this. So if I want to go edit it, I have to.
So how is it open as?
Well, you can edit it.
It's just like
Well, you-
protected view.
So how do you
Oh,
type
I
it?
can view it, but I can't.
I
So,
see.
so how do you type your lab reports?
I do them at home on my desktop.
Okay,
So
okay.
because that's where I have Word.
Okay, that's all right. Yeah,
Yeah.
you have the picture already, so you can do that when you go.
Yeah.
But why don't you have like full wall? Is it?
I just
Shit
don't have it
burned?
downloaded.
Oh,
I
okay.
tried through the school and like my email wasn't working, so I was like supposed to like contact IT, but I never did.
Sorry about that.
Well, like so here. If
Yeah,
I-
when you use your EDU email to go to register and get all Microsoft products.
yeah, I'll show you. If I
This is a
open
private
up a new
area.
copy, right?
You can record
Open
with
file.
consent.
Okay, and then enable editing.
Yep.
Okay, now we can change it.
Yeah, John, we broke Chad.
Wow.
Yeah.
Yeah,
I can smell it.
strange.
Yeah, because it's unlicensed still. So I also,
I see.
yeah, but-
Because the right is expired. Okay, I see.
yeah.
So they like to review, but that's how they used to be a long time. Yeah, so they like to review the document, but we cannot change it yet.
Mhm.
So we can move to the next segment.
Yeah, we're good for
I like
A2.
the movies language.
Yeah. Yeah, same too.
Yeah, exactly. First, second. Yeah. The middle one.
I might just real quick sketch the truth table.
Okay.
To think about it later.
You can make it out.
It'll only be a few boxes, you know?
Wait, I'm so confused. But you have the image already, right?
Wait, but I don't have like the actual. I can't fill it out because I can't edit.
Okay.
Q prime. So Q prime is this one, right?
Yeah.
So we have 1 0
Then 1 0.
1 0. All right, that's
Yeah.
all I needed. So now we can do part 2. If you got your pictures.
Okay. That's for the JK.
No. You have to do the 4-bit.
Okay.
The 4-bit
All
latch.
right.
Yeah. So we just have basically do what we did, but attach 4 more.
Is there a truth table for this one? Oh, my bad.
You're good. I don't.
That chip has 4.
There's not one to fill out, but there's a question. So it says set them all to 0 and
Okay.
record the number, and set them all to 1, record the number.
Yeah, just build the game.
The other one is really good. Wait, hold on, wait. All right, let's try it. Before I do
Okay. So we're just connecting all 4
that,
registers.
Okay.
So we're basically wiring this whole guy up right now.
You throw that way.
You get what I mean?
Mm-hmm.
Yeah, you can throw that way.
Then after this is the JK. Or that.
Oh, yeah.
Okay.
And then we're done.
Okay. I
So-
hope the JK.
Yeah, fingers crossed.
Yeah, I don't have the truth table for. Well, we don't even need to come up with it. All we need to do is just run it on.
Yeah. So the question. Scroll past. Oh my god.
Or actually, yeah.
There's a bit where it wants us to test it at 2 points
Okay.
instead of all of them.
I see.
So
For
that is just lithium.
Yeah, it's just the lithium. Yeah, but it's like the same.
Lithium is quite combustible, as we found out. Yeah, we still quite decided. Yeah, except we still decide, hey, this is a great thing to put in all of our cars, phones, and devices.
Yeah.
Let's make everything insanely combustible. Not even like normal combustible. You put a hole through a phone battery, it acts like a jet.
Yeah.
So it's not only explodes to a fireball quickly, and then the fuel disperses quickly. It turns into a shape charge, to where a jet of fuel will shoot out like a pillar of
Yeah.
flame. You could cut holes. Quite literally, in the plastic sea, yeah.
At some
Alright.
point,
All the switches are in.
I don't know which phones were there that night, but they banned them from the yeah. Definitely they can cause big issues. So after that, we will then want to discuss some counters and let's so counters. So you can make a count based on every pass.
that'll be fun.
Yes, definitely the counter and shift register as well.
Okay, good. Okay.
Since I'm not here, we have names. So, what name did you get? Ori. Oh, it's like kind of similar to your name, Ori. See? Oh, I'm lucky.
Not even close for sure.
But I wonder what happened to those people.
Cool.
So I'm just plugging in all the Q primes right now.
Okay.
I did all the switches. And I'm doing all the Q primes. All the Q primes are yellow, so it should be easy to keep track of.
Okay.
And then here,
You don't need to
you can do the rest. So these are our Qs that we're hooking up.
So you've already hooked up the Q primes, and now hooking up the
Yeah, this
Qs.
one you're doing.
And this Q is at, I'm
So-
saying 14.
So, 'cause I think it matters like the order. So left to right,
Mhm.
I just was thinking like 1, 2, 3,
Okay.
4, and that goes like chronologically. So like this is 1, so the first Q is going to be 0. Q prime is going to be
So this goes here.
no. So like what I've done so far is
Zero starting from where?
so like so because we have 4
Mm-hmm.
like latches, we're gonna have 8 values, right? We're gonna have 4 Qs and 4 Q primes,
Mhm.
right? So I'm just trying to keep the Qs and the Q primes
Okay.
next to each other. So like for this first latch, for
Yes.
example, we have Q and Q prime. That's 0 and 1, so they're side by side. So the second latch,
Okay.
right? Q,
It's going to be 2 and 3.
yeah.
So,
So I already-
it's 3 the Q prime.
3 is Q prime,
Okay.
exactly.
And then this goes to
Q of this register,
and that is 13.
14. It goes left.
Oh, I skipped. Yeah, you're right.
Wait, no, 15. We're both blind.
Wait, this Q prime.
Q prime.
Q
prime
prime
done.
is
We're
Q
following
prime is
Q
14. So Q is,
Yeah, Q is 15.
we're not blind, just difficult to see.
Yeah.
What's not to count? Where's the one? So this one. So,
Yeah,
so
so-
just right here.
Um.
16, 15.
Okay, then I put this one in the wrong spot. Okay. You have to rewire our Q primes.
Oh no.
It'll be all right though.
Yeah.
Yeah.
Not worry about any variations. It's stable and what they have here.
Yeah. Okay, so we got our Q in. So now we need the Q prime, which is 14, right? Am I crazy?
I don't understand.
14. Okay.
Patience, Daltonson.
So J is.
All right.
We probably should have put this up here so it's closer. Because all these wires are like stretching, but we're pretty
Twist.
close.
Twist.
Yeah, I mean it's doable with a wire. We can make it.
After it's a twist.
Yeah, don't bother.
Okay, so this is
We'll keep using the brown.
brown.
for
Okay, you
Q,
have browns. I didn't even
yellow
pay
for
attention.
attention. Yeah.
So we saw what a wonderful
So we've
color.
done the first two. Yes, yeah, fantastic.
So this is going to 11.
Are you Q or Q prime?
Q.
Q.
I thought you've done all the Q primes.
Q is 10. I pulled them out because I didn't trust myself anymore because I got the first 3 wrong.
Oh no.
So Q is 10.
Oh yeah, you're right. Q is 10.
Q is 10.
So that's just here,
Yeah.
and then this is going to the one right beside it, which is 4.
Yeah. Now this is our Q prime. So that goes to 11.
You're leaving it up to me to
I
get
am.
it.
100%.
Then the next one will be the last Q, which is 9.
That's a nice one.
It was so funny if there was no space and it was just here.
And it's like, what?
All right,
That would
so
be-
that's going to 6,
Yep.
right? And this is 8, so that's just here.
It's one.
Sounds good. Looks good.
Okay. So what are we doing?
I guess we have to test. Well, I don't know what the outputs are
Set
meant.
all the switches to binary 0. Okay.
Set it up to binary 0.
So measure that. All the Qs are 0. All the Q primes are 1.
Okay, that's our binary 0. All the say that again. Say what you just said again.
All the Q primes are 1. All the Qs are 0.
And that's our what?
We said all the switches are at 0. They're all down.
Oh, that makes
And I hit the
sense.
pulse.
That makes sense.
That does make sense.
So I meant to record.
So yeah, write that number down. Right. So we'll just go Q2.
Oh, we could even edit this on.
Yeah. Pull up your. Well, I mean, how are you even gonna write this stuff?
Oh, we just literally say what you just said. All the cues.
Well, it says record the binary number in the register. Oh, 1010, like
Yeah.
that.
Yeah.
There's also a T flip-flop. T that's meant for targeting as well.
I'm gonna take a picture of your book when you're done.
That's fine. Okay, and then we have to set them all. Think. And they all flipped. Look at that.
Back to 0101. That makes sense.
1.
So.
Documents.
0, right? So 0, and JK is 0. 0, JK is 0. Then
Okay.
What is that? First it was 0,
Everything.
0,
It makes perfect sense.
The
Okay, we should
universe.
probably. Well,
The universe, everything. We can now.
I get it.
We can now take over the. All right.
I think the idea is that when they're all high, they're one way. When they're
Yeah.
all low, they're the exact opposite. Just so you flip all of them.
So now we move on to.
Did you get a picture of our?
Oh, thank you for mentioning that.
Yep. No worries. A3, load 6 binary numbers.
I like how compact the box is. Really, really nice.
Load 6 binary numbers into the register one at a time by setting the data switches. For A3, are we supposed to record the values or just set them?
Just set them.
Okay, because there's no space to fill anything
Yeah.
out, but it tells us to test 6 numbers.
I mean, 6 numbers means just 6 combinations.
Yeah.
Yeah, I mean, we can record in this case, it's easy.
Mhm.
Once we do couple, it was gonna work from the beginning.
Yeah. Okay. So what 6 numbers do you want to test?
Like 6 binary numbers.
Yeah. So we have 4 inputs. So we just not including those 2.
Oh well, yeah, let's make it easy for ourselves. 0001.
Yeah, 0, 1, all 0.
And I just begin to implement.
0, 0, 1, 1, and 1, 1, 0.
Like this.
Or I could even make it easier for you. I think you're already getting it. You could have done 1001.
Yeah.
Yeah, but yeah, you get the idea.
I just grabbed 6 numbers. They're not evenly spaced.
The flip flops.
Okay. Whoa.
So what's it meant? Are we
We're
meant?
switching now.
Do we know what they produce, or do we know what they produce or what they meant to produce?
Why are these 2 switching now? You see that?
So this is on.
But these back 2 don't. Why?
This back 2 are for which one? Are these the first initial connections? What are these back 2 connected to?
Should be.
So how do we record the flip flop into the table?
Then the inputs and the Q. So the output.
So is the
I don't think we're supposed to have Q prime as an output.
Select Q inputs. Yeah.
For this one,
Yeah, look, the Q primes are cut off. It's only grabbing Qs.
The output.
so why? But didn't you just see it's connected to something?
JK was 1.
Well, so here we just wired this. We don't have the schematic they gave us, right? So the schematic they gave us, we don't actually use Q prime. So we just wired Q primes for
No reason.
no reason.
Right?
It's all right
Both of
though.
them are on, both these are on. But the depend on the
Huh.
So that
Oh, also we have to make our pulse switch go to all of them.
When the clock goes high, because we have both.
You know what I mean?
means
They all have
the output is both 1.
a pulse. And we only plug in the 1.
Right.
Okay.
We only have one.
Everybody is both 1.
It only goes to 1 register
That's basically.
or 1 flash.
Because that's.
You get what I'm saying?
Advanced process.
So I think.
So first of all, we should disconnect all the Q primes.
Yeah, I think instead of having 8 outputs, we're supposed to have 4 inputs, switch 1, 2, 3, 4,
Bingo.
and 4 outputs, Q1, Q2, Q3, Q4.
Okay.
Does that make sense?
So that's why only those 4 were changing.
So, well, the reason they were changing is because we didn't have them all connected to a pulse. Does that make sense?
So it's each connected to all the D's are connected to the pulse.
Yeah.
So what
No,
was
these are our switches.
so they are connected to the switches.
But it's wait no.
The pulses are the switches, right?
Pulse switch A would be used.
The pulses are the switches.
Yeah. Where did I put the pulse?
Isn't the switch connected to the pulse?
So when you do that code, you can do simulation partners as part of the experiment.
I think so.
So you do simulation and experiment all in one. That's usually how they.
Oh no, I put switch A to 13 because that's where it told me to.
Let's calm down. So okay, sorry, yeah.
So you can add simulation as part of that.
What is that's meant to be the clock?
A is the ground.
That's meant to be the clock. G is meant to be the clock. Are we using the clock for this one?
It still says, well, it says or strobe signal.
Let's scroll up. For the first one, was there a clock?
No, first one.
G was connected to what? What's A? A was the pulsar switch.
A is the pulse, which I put in pin 13, and it worked. Right? But now we're moving to here. So pin 13, if you can find, what is pin 13 connected to in the actual diagram? Pin 13 is connected to ground. So
Okay.
instead of all of our grounds, we should connect those to the pulse.
I see.
Does that make sense? And that should fix the pulse, and then we just get rid of our Q primes.
So repeat what you just said.
So we have them connected to ground,
Okay.
except one of them is connected to pulse. We need to connect them all to pulse.
Pulse.
So
So
that
these
way
are all the
they only
switches,
switch
all the
when
switches
we
to
hit
pulse.
Yeah.
Okay.
All the grounds to pulse. So like, when we,
Okay, all the good G.
all the G's. Right? So
Yeah.
if we
Yes,
look
you're
at-
right. You're right.
Yeah.
I don't have it installed in my computer, but I was in.
Yeah, see, our,
I have it installed.
I don't think we ever actually wired our G's.
We didn't.
So, oh yeah, this makes sense. So 13, right, which we have plugged in, is only connected to the first 2. That's why the first 2 were functioning off our pulse.
Okay.
The second 2 were flipping automatically
11 and 10.
because they were floating. It goes to
Okay.
11. So
Which
connect,
cable? Which?
Whatever blue one,
Okay.
right? Go from pin 11 into the same pulse, and then it should work.
16, 15, 14, 13, 12, 11.
11 should be open.
It's not open.
No, not 11. My fault. 6. No, 4. It's 4. I'm sure it's 4.
1, 2, 1, 2, 3, 4. Okay.
Yeah.
I will take your word for it.
Okay.
Why am I connecting these two?
The pulse. So right below our other one. So
Right there, the connection.
perfect. So now we should be good. Also, are we supposed to only? Are we supposed to only have our Q's go to the lights?
Yeah, I mean, Q and the Q prime, just the Q's.
Okay.
Because Q prime is always, just to verify,
Yeah.
yeah, always opposite. Yeah, if you don't have opposite, that means it's not working.
Yeah.
So fundamental design of flip-flops, Q and the Q prime are always opposite each other.
Makes sense.
So you don't have to have, one
Yeah.
is better.
Okay. So in that case,
Yeah, you don't have to have both.
I'm getting rid of our Q primes right now.
Okay.
And then just for ease, I'm gonna move.
So for this lab, we'll do both simulation and experiment.
Okay.
So you do the simulation using quarters. That's what.
So we'll simulate that after this lab and then put them into the lab report. No problem.
That's how they are, but you know. So
Okay.
You can build one report, but doing simulation before gives you also, you know, an idea of what to learn.
Okay. So are they now working properly?
No.
What's happening?
So last time we had the pulse in 1, right? And they were automatically flipping, so we moved it to 0 and it made sense. But now they're already automatically flipping. But I bet you if we put the pulse in 1, they wouldn't. So why would that change? now?
Well, they are
So-
0. It's the
Yeah,
same
yeah,
thing.
that's yeah.
Did
But
you
for,
measure
but for
it?
the first lab, they were working at 0.
Yeah, it's working at 0 right now. They're connected to 0.
No, it's not. It's not supposed to flip until we hit the pulse.
Well, let's
Right.
see. You are using the latch or the flip flop in this
The
experiment?
latch though.
The latch. No, latch should flip if the pulse is already high.
But the pulse is low right now.
Okay, pulse is
And it's flipping automatically.
Yeah.
then, yeah, something is not
So
right.
these are 1.
Yeah, no, something is not right. Yeah, they should. Well,
But in the previous
yeah, I
experiment,
see what you
when we
mean.
just
I
had
think it's the
one,
way we connected it.
it worked.
but no, usually it has a sign whether it's a negative or positive. No, it should not change. Let's
Well, they should all be connected to the same, or they are connected to the same spots.
Yeah.
yeah. So you connect all of them to the same clock.
Yeah.
Yeah, all of them to the same clock switches. So G is the same to all of them, and so all of them connect. And you verified that, right? You
I
verified
believe they are connected
they're
properly.
connected to the
Yeah.
same. And then, yeah, if it's a flip flop or latch, actually, they should not change until. So let's verify just quickly what the clock value right now, like with zeros, for example.
It still confused me that we're using the pulse instead of.
We can switch the clock. If
You
we
can
want.
use the clock, yeah, definitely, but pulse is also.
Pulse. I feel like is more controlled though.
Yeah.
We can decide when.
You can
Decide.
make the clock very slow.
Slow,
as well, yeah.
okay.
But pulse should be the same.
Let's connect and touch.
So right
That's
now,
reading high.
when it's in zero,
Yeah.
that's should be. No, but it has you have.
Are you guys
keep
done?
It's just always.
How did you guys get the last parts to work?
We wired it up like the one over here. And then hooked it up.
Let's see.
So like, we
But it's not changing at all.
Yeah.
No.
So maybe there is a short connected to it. Then let's disconnect one of them.
We should use the one that is
Actually, let's
directly on the
measure it
lab,
before
on the lab
connecting to
manual.
anything.
Yeah.
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 The numbers that match up with these
Yeah.
and these
So right now,
are different than numbers.
yeah.
on
So
the-
right now it's high.
Okay,
So
so-
probably something is connected to
Use
it
that.
improperly.
Okay. Well, we're not moving to this one. We're doing this one.
Oh, that one?
Yeah. So with this, it's our issue is that it's
No,
connected
no, we
and
found
working.
something like.
But
one-
if it doesn't latch, it switches on and off
no, because
immediately.
we found something, Ori.
Oh,
What happened
vanished.
is- Yeah. So when we were measuring the pulse, and it was connected to a circuit, it was not switching at all. It was always high.
Oh,
So the circuit is doing something. So right now,
So it's still low.
low.
Now it's high. So
Now
that's
it's-
good.
Yeah.
So
Yeah. So now let's
problem with
connect it
this
again.
wire then somehow. Oh,
what happened?
we're good. It was a straggler.
So that's what was messing up the circuit.
Because
Maybe.
the pulse, maybe, yeah. Because
All right,
the
let's
pulse
try
was
it now.
always high.
I think we had.
So flip the switch.
But nah, it's not even coming. Oh,
2.7. So 2.7 indicates something is not properly connected either. But should be, you know,
Yeah, yeah. 1, 2, 3, 4. I think we plugged the pulse in the wrong spot. Wait.
Makes sense.
it's just-
okay.
Okay, wait.
Is
Did
it?
it, did it start? Hold on. I think I know what the problem was/is.
It should be at
4.
4 is
4.
4 is the input.
Okay.
Oh, no, I'm sorry.
I'm
4 is
sure
the
now.
4 is the clock. Yeah.
Yeah, yeah.
Yeah.
Yeah, you can connect that.
to
So right now
0
0.2.
points.
Yeah. Okay. So
It's working now.
So
Yeah.
now the
So what
bus
was,
is
what was
working.
the issue? Was connected to the wrong spot.
Yeah, we put it into pin 5 on accident.
Oh,
where the
yeah.
VCC is.
That's my bad.
You're good.
So we can let there be light.
So now what our values? We're using the second clock.
Oh,
No, set the switches.
oh yeah.
Yeah. So that's and then
And then when you pulse
And then
it, should all
pulse it?
turn on.
yeah. No, just pulse. Just give it the pulse. Something. So the switches are on or off now?
Up is on.
Up is
down is
on.
off.
Okay.
Now it's on.
Okay.
How did it work before? Oh, Oh, this connected. This means connected to 2 or to 1.
I think 2.
Okay.
Um,
So what is 1 connect? Okay, 1 is
Two
Q
is the
prime.
switch.
That's all right.
Yeah,
Yeah.
2 is the switch. Yeah. Q prime, you don't have to worry about it.
2,
2 is the
3,
switch.
4. Wait. This is connected to 5 again.
what is?
5 is
2,
permanent
3.
5.
Oh, never mind. You're
Yeah,
right.
5 should be permanent 5.
Wait. 2,
Oh,
3.
I found it.
Ah, okay. I see.
You did it the same.
Yes, you know you get. Yeah. So now you
My
get the switches.
bad.
Yeah. So now it's already, and then change one of them.
Okay, and it's been latched, right?
Yeah, change all of them. Yeah, or whichever one you want.
Yeah.
Okay, and then pulse it again. Go to 0. Yeah, that's it. And then flip one of them. Pulse it again.
Yeah.
So this is
Okay.
the logic.
So
It just takes it only on the pulse.
yes, only on the pulse. That's when the clock. Yeah.
That's why
Yeah.
when you buy a computer, you always buy with high speed because only things will happen on the pulse.
Yeah.
As a matter of fact, they use both. Like in communication, we use the high pulse to transmit,
Let me take a picture of this
the low
one now.
pulse to receive.
Yeah, so you're not wasting.
Yeah, not West exactly and clock cycles. Yeah, yeah. But usually, things happen.
So what's the advantage? Because I know that so this is a latch, but flip flops are edge triggered. So why do we need a
much
flip?
more control.
Much more control.
If you have the flip flop, you have much more control.
So
you take the inputs on that edge.
on an edge, okay,
Whereas the other one, you take it based on the level.
on the level. That's also okay. Level. That's why it's also called pulse trigger as well, right? Level of pulse.
Well, they are both pulse, but in this case, if the pulse is on and remains on, and the input is changed, then you take the output.
Okay.
Yeah. But the flip flop just based on the edge.
Okay.
Yeah. So when the clock goes high, that's when we have it.
I'm making
So
the
many
truth table.
applications can be very limited.
Okay, we're testing the values.
Yeah. They wanted 6 values, so.
All digital applications, they work in the same way. So in communication and many other applications, of course,
I feel like we should simulate this and make sure it's correct.
yeah, we can select easily.
I mean, we're
Well,
gonna have
we-
to simulate.
Well, we cannot.
eventually, but
We can just say if anything's wrong, we can just say, well,
You can use
it didn't
the-
corroborate, but there it is.
Is it like possible that when simulating our Q's and Q primes are gonna be flipped?
When you simulate, we're gonna take the output as Q.
Mhm.
So you can always say, I mean, because you write it in software, so you take the output as a Q and you can say Q equal not Q.
Okay,
Right,
yeah.
So
Makes sense.
because in simulation and you have more control.
Mhm.
Okay.
Yeah, so I sent an email to see if we can find one of those or buy maybe one of the Quartos real hardware. Then,
Okay.
Then we can build the exact same bit using the real hardware. Yeah.
So you got 6 values.
Yeah.
Those are 8 values.
6, and then they wanted 2 specific.
Please, we know these to work.
Yeah, and they all match up. So like if it's low, it's low. If it's high, it's high.
Oh,
Like the whole.
so it's correct.
After like 2, I was like, I don't have to do this anymore. But I said, why not?
Oh yeah, that's correct. Yeah.
Yeah, I feel good about it. It makes sense.
Because it all matches the MPUD. Because I was doing the assignment yesterday and I was reading that it was now making because when you were teaching it in class, like I
Yeah,
couldn't-
it was wacky for sure.
I couldn't. Yeah.
You got a picture?
Yes, I did. I deleted the previous one. Okay. Oh, would there be enough space to have the rest? I was thinking when you're done, but I can just.
Yeah, I mean,
Yeah.
I'll probably be on a new page for the flip-flop one. Okay, so we finished part 1.
All right, time for the JK flip flop.
That's right.
I think 2 people joined and left.
Yeah,
I saw one.
they left.
Hey.
We're having so much fun. Okay.
So next lab we'll do probably counters, but we have not covered them yet.
Oh, okay.
And we'll keep those for the semester. Second part of the semester, we are more organized than today.
Yeah.
Those can be used also on analog. If you are using the analog class, you can use them
Okay.
because you have power supplies, you have
Mm-hmm.
everything. So, yeah. But then you will not be using that piece at all. You will not be using that piece. This can also have a variable output, so
Yeah,
negative voltage, positive.
very versatile.
Yeah.
Are we ready?
We are ready. Check out our polls.
So are we just putting on everything?
I mean, not like everything, right? Like those we're probably gonna need again, maybe. Basically everything, yeah. And by basically I mean yeah, literally everything.
So,
Why you messing?
because you're hiding yourself. You're only recording Evan, and I think that's very, very.
Huh? We're both in there.
No, now you are. You were a second ago. I was like cutting off half his face. And I was like, wow, that's very slick of them to do.
But he's
That's fine. That just means I'll be the one to be famous.
Yeah, exactly. So,
Yeah.
No, man, all your rights belong to me because you're on my channel.
Oh, go say, I have a present for you.
What? Why are you giving that to me?
I thought you'd like it.
You can keep it actually.
that's
This is that the fried one.
The fried one.
That's why it's a fried chip. Oh, don't leave me, don't leave me, don't leave me, don't leave me. That was a good joke. That was a good joke. Did you guys already make that joke already?
No.
Okay.
No, you can copy.
Oh, I forgot.
You can copyright that one.
step comes and then,
My fans missed
Can
the
only
joke.
happen if someone is watching.
You should go back.
Okay, so apparently this is we should follow exactly what's here, not the one in the. That's what Dalton said.
Yeah. Okay. So switch 0
Okay, I moved it forward.
is
Good.
in 4. Yeah, yeah, so it's closer. Switch 1 goes to 16.
You have 14.
Let me make sure all our numbers are adding up. So 16 is here. Good.
Yes. Double check them all.
And this is 4. Is this 4?
Yeah.
1, 2, 3, 4. Bingo la bungo.
Okay. Switch 2 now. Wait, no. Yeah.
Switch 2.
Switch 2 should go into 3.
Yes. So that's right next to this. Hakuna Matata.
Okay.
What a wonderful phrase.
And then
It means no worries for the rest of my days.
switch 3 is going into 2.
Oh, that's correct. Then switch 1 goes to 6. Okay, we've already done that already.
So switch switches
switch
1 through 4 should be.
Switch 1. What?
Huh?
What's
It's
switch 1?
0, 1, 2, 3.
Oh, sorry, 0.
Yeah. You're good. So 0 goes to 4.
Yeah.
0
So it's
is this one.
0.
That goes to 4. Switch 1 goes to 16. Switch 2 goes to 3. Switch
Yes, yeah.
and switch 3 goes to 2.
Okay.
We're good?
I believe it looks good.
All right.
And this
so
is JK. I don't know what this one's going to look like.
that's all right.
Oh, we can search up a table. Let me
Yeah,
search
I
that.
already did. I have it right here.
Oh.
But
Can your laptop to the side zoom?
yeah, yeah.
It was a good first live stream. I'll probably try doing it from the app to see so I can zoom in, seeing if that will work because I can't zoom from the camera. So
Yeah.
that's what's good.
Okay, so we have our switches. We need A as our clock. So you want to actually use the clock this time?
I think we should use the pulse because it'll be harder for us to know.
Okay.
Yeah. I
Yeah,
think-
yeah. It's definitely more controlled for taking values.
Yeah. Well, at least it'd be nice when we're done. We can do the clock functionality to get
To
to
just see it move.
Yeah. So we're connecting this clock to
1.
I don't know what happened to both.
What if I just don't wanna go to school?
I know on the same day.
1. All right. So
Okay, so switches and that's done. So now we just have Q and Q
Wait,
prime.
we're using this same. Is this the different switch?
Yeah, yeah.
Because I was like
I,
this.
I moved them.
Okay. All right, JK flip flop. Let's
So-
get this done.
Q and Q prime.
So which am I switching on now?
Well, nothing yet.
Nothing else.
We.
Did you connect the Q primes?
Nope, I didn't connect Q or Q prime.
Oh,
So
I was so excited.
I know that's why I said not yet. This is
So
Q.
Q, this goes to 15.
Correct.
That is right beside here. Someone just joined and left again.
And that's Q prime.
And that goes to 14. How convenient. All right, now
Now
we're
we're all
ready.
set. And now we can fill up this table that I have to draw real quick.
0, 0, 1, 0, 1. Well, what you could do is wait and see if it matches up. Then you will need to copy it. You just use from here.
Yeah, I mean,
0, 0,
fair enough, I guess. It's too late now, though. Q,
Q prime.
Q, Q prime,
That's J equals to K equals to 1.
J equals K equals 1.
Then the complement of that.
J equals 0. Oh, look at you.
Oh, yeah.
Using
Oh,
your-
yeah. Oh,
your
yeah.
digital logic
Oh,
vocabulary.
yeah. And they're both literals. G when I
Table
want,
two.
when I want to.
All right.
Ain't no reason to jump. All right. All right, test.
I'm all ready.
So this should be, oh, with this pulse, okay, because it's pulse, it will always be edge triggered, right?
Yeah, pulse.
Because it's pulse, it's always going to be edge
Oh,
triggered.
okay. And if it's, what makes the difference if it's flip flop or not?
Yeah.
The clock is the same.
Yeah, the clock will be, but like because we're using pulse, it doesn't.
Yeah.
Oh, well,
Yeah,
let's,
it's actually pulse. Yeah.
let's test. So this is the pulse.
It's off.
Oh,
You don't need both, just one. And you
Oh,
use
yeah.
only one. Yeah.
so this. Oh, that's the pulse.
Yes.
That feels like it's not.
Then this is off. So
Whatever
if
time
it's
it is.
0, 0, it's 0, 0, right?
So for this is the
So right now we want JK equals to 1.
One.
So,
So-
switch 0 and 1 should both be 1, right?
I'll put them as one.
Okay, cool. And then
that's are the inputs.
yeah,
Right?
yeah. So
So
now,
one is you can leave the last state because that's the used to be not allowed in RS.
Yeah.
Now it's a toggle here. If,
Okay.
if you know what I mean. Yeah. But you can start with that also.
Yeah.
So
So
if you target, if you give it the pulse now. it's a
I've
toggle.
made both one.
Okay.
Yeah.
Both of them are one.
Okay.
so,
what should I do?
so if you
Yeah.
use pulse now,
Okay.
Pulse
right?
now. It's a toggle.
Well, so right now we're here, right?
So
Because our
it's-
S and C are
Oh,
zero.
So what does this give us? So this gives us 0. No. Yeah.
Or do we? Is one of those lights on?
None of them are on.
It should be. It's Q and Q prime.
Okay. Yeah.
Q and Q prime, yeah. One of them should be on all the time.
Yeah.
One.
Oh, we didn't connect power.
I
swear we make the same mistakes every time.
Power is it?
Yeah,
It's really here,
You can you can use these if you want.
and is it even connected to the return as well? Oh, power across where? Oh, where? Power across
To the chip.
Oh.
Our chip is unpowered. So 13.
Pin.
The black I just handed you.
Yeah.
Send that to 13.
So this
That's ground.
ground. Okay.
And then you can just use this red one. And that's 5.
Everything I talk, everything I talk.
Okay. At least it makes sense when we got 0.
Three,
That is the good news. Every time we make a mistake like that, we realize why.
Yeah.
And it makes
Yeah.
sense that
That's-
like our mistake,
That's basically the limit.
it tracks. Okay. There we go.
So I should pause it.
So
down.
now, so our Q prime is yellow, yeah?
Yeah.
So we have 0, 1.
Oh, they're both
No,
on.
but both on is not good.
They're both on?
Yeah.
Oh.
So we have
The way it's lined up, I couldn't see the
both
other
on.
light.
Yeah, I see both of them are on. So both of them are on. That's
Why?
so there's got to be somewhere where it's showing.
I'll say at 5.
So 5.
Yeah, that's 5. 1, 2. And this is 16, 15, 14, 13. That's 13. So
Both of them are on. So it's not right. So those are Q and the Q prime.
Yeah,
Yeah.
and they go to 14,
It should
15.
never be on at the same
That's the
time.
right spot.
14 and 15, yeah.
Or
I
this
don't
switch.
know.
14 and 15.
Our switch is not correct.
Even if the switches are, no
Well,
matter.
well, like I mean, like
Mm.
so, like because we have two inputs and then we have these should always be on. Like if these are switched, then it'd be like J is 0, K is 1, S is 0, C is 1. Like that might.
Possible, but still at the end, the
But I feel like we
fundamental.
double check though.
Yeah, maybe we can check
Switches.
those because fundamentally,
Yeah,
I mean,
so
of course,
switch-
it designates
switch-
a problem.
0 is 4. Double check that. And that's our J.
0 is.
It's this one right here.
This
Oh.
one
So that's
That should go
0.
to 4.
Let me count.
looks like
1, 2, 3, 4.
4. Okay.
Okay. And then switch 1 right next to it should be 16. Be a pretty easy one to check.
The last one,
Yeah, it's in 16.
Okay.
Okay.
Switch
And
2,
2.
3.
Switch 2 is
No,
this.
so no, switch 3 is.
Oh,
Switch
Yeah,
2.
I
Oh,
see
okay,
it.
yeah.
3.
Yeah.
Yeah.
yeah, it starts 3.
Is that plugged in all the way?
Yeah, it is.
Okay.
Okay.
And
Oh,
then-
no, it wasn't. Nah, it's still both red.
Yes.
Okay,
very good,
okay.
yeah.
And then final switch 3 is in 2. In 2.
Yeah, it's
Now
connected.
those have to be reversed, aren't they? 3 and 2
Oh, they are negated.
because negated.
Oh.
That was a good cache. That was a
So-
good cache.
Yeah,
So-
I thought you connected.
So
the other
then
way.
we just tested one,
That-
one
that-
technically.
Yes.
Yeah, you just tested 1.
So
That's correct.
One- one can't be tested, right?
cannot be. No, if you are using the RS, cannot be tested. This is the RS or the no JK
JK.
will fix the problem. JK should tackle it.
So it should be what?
Yeah. So we still have Q
Yeah,
and
we
Q
still
prime.
shouldn't be getting
Yeah,
that.
we still should not be getting that. But yeah, so there's something else because it's a
Let's test 0. Let's test the
but
0.
still, I think indicates a problem. If you-
So
I mean, like it.
yeah, if you have
This
them
should
both-
be testing 0, 0.
okay. So is the 0, 0 fine?
this is 0, 1.
Okay.
Yeah, that's correct. 0, 1.
Yeah. So it's
0, 1.
yeah.
Okay.
So what do you have on the
So
Then
0, SC? Okay. Okay. 0,
wait.
0.
What did we change though?
So because they're negated,
Uh-huh.
instead of putting them through a NOT gate, I just flipped them.
Okay, so
Okay.
which ones
So
did you
w-
flip?
when they're 1, they're 0.
Okay, so all
Yeah,
these are
correct.
zeros now.
Yeah.
Okay.
So we're testing.
Yeah, so these
0,
0,
1.
0.
So we're testing 0, 1, so it should be up, down.
Mhm.
These should stay up.
Wait, what are these two?
Only SC is negated.
Yes.
Those two are JK. Those should always be on.
Mhm.
Okay.
Yeah. So now hit the pulse.
1, 0.
But that's fine. That's not supposed to toggle. Only when you have 1, 1, when J and K was supposed to toggle.
Yeah. So then flip these.
Yeah.
Hit the pulse again.
Honestly, I'm confused right now.
That's fine. What do we have?
0, 1.
Still no toggle. Because
This one flipped because our Q. Wait.
you should toggle only if you
Q is
have,
on now.
Yeah.
So it's like this.
Yeah.
That's what just happened.
only when we have the J and K because the RS has a problem with R and S being on at the same time. JK solved this problem. That's mainly what we benefit from JK. So JK solved the problem of having R and S on at the same time by toggling the out. That's mainly what the JK does. So if you have them both on at the same time,
Well,
Yeah.
I think we have it the right.
I don't know if this is the same table.
yeah, so it's fine. So when the clock goes
Zero.
high, so this is 0, 0, and
That's
then
1, 1.
yeah.
They
I mean,
should
as
both
long as
be
we match this should be fine. So 1, 1, it's a toggle.
Yeah.
So 1, 1 here.
I
is a
just tried
toggle.
1, 1 again.
It's not toggling.
They both turned
Yeah.
on.
Yeah, I don't
Okay.
think we have the right.
So they both are on at the same time. Yeah.
I don't think we
So
have.
I mean, we should never see them all
Yeah.
at the same time. That's fundamentally. So it does
Alright,
not matter if it works or not, but at least they should not be on at the same time.
So let's figure out where there might be another issue.
And if they are, means something is not right from the wearing perspective.
Yeah.
So
That's okay.
only when you have J and K as 1, 1, that's when it toggles. That's otherwise it's exactly the same as the RS.
Mhm.
So JK flip flop was implemented just to solve the problem when both of them are on, and then it toggles. Otherwise, it's exactly the same as the set and reset. So there is something wrong with the circuit for to have Q and the Q prime as on. Something is not. So we checked everything, power, ground, everything.
16.
I guess we
15,
did
14, 13.
move our chip up here, so we might want to retest if it's getting power properly.
Just yeah,
Okay.
couple points. Yeah. So power, ground, and yeah. So use a
Automatic.
wire. Use a wire. Yeah.
Testing, testing, testing.
So first start with the ground and power at the.
Testing. That's the return.
That's the ground. Okay. And then the power.
That is the
Okay.
power.
Power is good. And then switches. So power is good. And then so all the switches are properly connected. For example, switch 0. Let's say pin 4.
So these switch J key, they should always be on. Yeah.
Okay. So pin 4, for example, right now. Pin 4 is on, or pin 4. You can double check it quickly.
Pin 4,
Pin
that's
4.
SW0. Is that J or?
That SW0.
Yeah.
So that's basically J.
That's for.
So right now it's high.
Yeah.
Okay, so because the switches are up. Same thing with the other switch. So are you using those are
The
yeah, those
first
are the
four, yeah.
first.
0, 1, 2, 3.
0, 1, 2, 3. So 2 and 3 are 2 and 3 are well, do you have the schematics of the
Yeah, it could be at the top. Just go a little higher. Is that what you're looking for?
yeah, maybe this. So this is the 7476.
Yes.
Okay, so now this is this is the clear and reset, and I mean yeah. So so if this is low, that means you're gonna force it in a cleared state. Look at the description. So if it's low, then we force it in a cleared state, or you can force in a yeah. So let's see how they describe it, because this is a special flip-flop. How the CLR and the PR are described. Let's look at the data sheet if you don't mind. 7476.
Because there might be a reset you have to do here. Let me check one thing very quickly. And then check the data sheet of it. So if you go to the 7476, it describes. One second. If you look at the data sheet, it tells you what state those have to be in. I don't think you can have them both on at the same time or off at the same time.
So for example, one of them has to be always connected to so this the clear has to be always not active. So if you put the clear as low, as high, this is the clear. Yeah. So try to test it with the clear being low all the
They're
time.
negated though.
Yeah, it's fine. So you
Well,
want it,
clear is 15.
yeah. So let's test it with one of them. We can
Well,
yeah.
clear should be 3.
Sorry, am I okay? Yeah.
Yeah.
Sorry.
So let's see now if it latches and if it tackles actually. So both so clear and yeah. So 3 and 2 keep them as known as is, and then let's have 1 and 2 in a 1 and 2 are both on right now.
So 3 and 2. See how do we?
Yeah.
Why is
No, it's okay. So this one is 3 and 2 are presets.
okay?
So
So
those have to be
3
set
is
up front.
on. So because it's negated, it becomes 0.
Yes, but those are not the input. Our input are really 0 and 1.
Okay,
So what we have now in 0 and 1, we have 0, 0, right?
Yeah.
Then it should toggle. Let me see if I do the other one. Yeah. So right now is the same. Okay, let me check one thing. So both of them are on, like this. It should toggle. So wait 1 second. So 3 and 2 are mainly this, right? PR and CLR, correct?
Yeah.
PR and CLR. Then J and K, so our switches are 4 and 16, correct? So if J and K are both on, that should toggle. If J and K are not on, this should behave as the RS flip-flop. So the RS flip-flop will work. So we're only just going to test when J and K are both on. When J and K are both on, which is this configuration here, and the clock toggles, it should toggle. That should toggle based on some configuration here. It should toggle. What I'm assuming is both CLR and PR cannot be having the same state at the same time. So CLR, you want it to be non-zero, so you want to be one. One, so what's what is CLR? One of these, right? 2 and 3. So let's say it's a 3. Because when you have them both on, you see, we are going to, this is both off, that means, so it's if it's on, yeah, if it's 0 from here, that means it's 1 because it's negative. So that's not allowed. So as a matter of fact, if we don't connect them at all, this one and this one, for a second, just do not connect them. And then, so now we have them both on. Yeah, see, it toggles based on that.
Okay.
Toggles based on that. That's what you would expect because
So
they
we're
are
good.
both on. Yeah, the thing is, those have to be in an unknown state. So this
Yeah.
this is reset and 3. So this has to be like.
Could you
reset.
open that table? The,
Yeah. So
one
if you
found
go
on
back, yeah, it's okay. So those has to be the PR and the CLR has to be like reset prior. And now if you don't connect them to anything, that's exactly how you expect. You see how it's toggling?
Yeah.
Yeah. So this will work under one setting of PR and CLR. So that setting we can find out what it is.
Okay.
That's basically. So now it's acting exactly as JK.
Okay.
Yeah.
Could you?
So how does the develop this table then? 'Cause
Yeah.
It wants us to test different values.
Correct.
Of
Correct.
S
Yeah.
and C. S and C are CLR and PR.
S and C, no, they are not.
Zero.
Are you sure? No,
I'm pretty
because
sure.
JK
Hold
0.
on.
no, those are the inputs. So yeah,
Because we have J and K.
yeah, G and K, those are the inputs.
That's these two.
Yeah, those are the
But the
inputs.
table it wants us to fill out.
Yeah, it's okay. We'll come to the table in just 1 second.
Okay.
But those are our inputs, 0 and 1. This is what we are latching. So 0 and 1. This one is 3 and 2 are presets that this flip-flop has extra functionality. So this is the extra functionality of the flip-flop, which we will see what it does in just 1 second. But at this moment, this flip-flop solves the problem of having 0 and 1 on at the same time, because that was not allowed in the RS flip-flop. So RS flip-flop did not allow that. Then JK flip-flop said, okay, we can solve this problem by allowing this and this to be on, but whenever the clock goes high, we toggle, and that's what we are seeing. So 3 and 2, those are mainly the settings that we need to get. So those are mainly all J and K. So J and K, and then where do you see the 1 and 2? Like switch 1 and 2. Where do you see? I'm sorry, 2 and 3.
That's SC.
Yeah. So
Yeah.
switch two is.
Yeah, I know, but
switch
where do you
three
see
is
them in the
S.
table here?
Right
SC.
there. It's telling me inputs are S and
Well,
C.
as S and C, in this case, as clear and yeah, so that's fine. We can consider them that way.
Yes, but
So-
you're disconnected now.
I know. So I disconnect them because they have to be in a proper state. So if you put them
So
as both
we need
zero,
we need to get the initial states for both.
correct, not initial state only, description of the state. So if they are both zero, like let's say the way it is right now. So if I put zeros in both of them, so zeros in both, zeros
That's it right now because you put
right
them as
now.
one. Yeah.
Okay. You see, it still toggles. So that works in one.
So that's good.
Okay.
Yeah, that's basically the same thing as when we have disconnected. So that's
So that's good. So
Yeah.
so like in the what's it called?
So how do we?
That table was correct because at 0 you have 0, 1,
yeah,
1,
yeah,
0.
yeah.
Okay.
Yeah.
So-
So that's basically 0, 0 is the same as disconnected. 1, 1 probably is still not allowed if you have them both as, because remember, this is the extra functionality of the flip-flop. If you go back to the table, the extra functionality of the flip-flop. So now if I make them both as zeros, that's not allowed, and that's why we are getting 0, 0.
Okay.
Now, if you have one of them on, then depends which one you have on, it will force the flip-flop to be in that state. You know what I mean?
Yeah.
So you have 4 states.
So
right?
how do we test the rest of
No,
the
it's
states?
very simple. Look at it this way. You have 4 states of the S and C, right?
Yes.
If they are both off, then it works exactly as we expect.
Mhm.
If you have one of them on, then we force the flip flop to be in that state. For example, if you have the set on or the clear on, then the output will remain the same no matter what you do. You are forcing the flip flop to be in that state. So as
you're
an example,
saying-
yeah. Now you force the flip flop to be, yeah. So if you flip it one more time, if you flip, yeah. See, you're forcing it to be in that state. So now it's gonna be forced in that state.
Okay.
So if I
And then if you do the other way, then you're gonna force it again.
it switched
In
to
the
that.
opposite
Yeah,
state.
in the opposite state.
Okay.
So that's basically the set and reset.
So when
you
we're
know.
filling out the table, so for
Mhm.
0, 0, we just write like toggles.
Toggles only under the condition of J and K being both on.
Yeah.
Yeah, only when they are both on.
J and K equal.
Correct. Then it's
So
toggles.
then this
Yeah.
one is then for 0, 1, we would say
Yeah. So it's looked at that way. 0, 0. That's the functionality of the JK flip flop. 1, 1 is not allowed.
so this is 0, 0, 1, it becomes 1, 0.
Becomes 1. It's forced 1, 0. right?
Yes.
Correct. False.
Then 1, 0 is
Mhm,
forced
mhm,
to
mhm.
0,
Exactly.
1.
Yeah, because
Then 1, 1
Yeah.
is not allowed, but it gives
1,
us
1 is not
yeah,
allowed.
but
and
it gives us
and it's catching that.
yeah, it gives us
Exactly.
1, 1.
Correct. It's catching
So
that. Yeah.
you can put 1,
Yeah.
1 there.
Correct. Correct.
Yeah, but the value, yeah, 1, 1.
So 0, 0. Yeah.
So now we can
Yeah.
test for J.
You can test for anything basically.
So now let's test for J equals to K equals to 0.
Then it will act as set and reset. So they work opposite of each other. Anyway.
So this should,
They work opposite of each other.
so this is when they are both 0.
So yeah, both zeros.
Yep.
So our
Okay.
1, 1 is still 1, 1.
1, 1 is gonna toggle now in the JK.
JK.
Yeah. So forget those now at this. So now 1, 1 is out, right?
So no, we're making this 0 now.
Which one?
We just
J
tested all
equals-
of them
okay.
with JK equals
Okay.
1.
So this is
Oh,
now
okay.
0.
Yeah.
Okay. JK.
Ah, you move this one.
No, both of them are on. Then you are forcing it to toggle. You see, if you set S and R as zeros, so if you
Well,
set,
right now, JK, this is going to 0 now. So we're
Okay.
dealing with these two now.
Okay, so JK are both on.
Yes.
Then it's
JK,
gonna-
Off,
JK are
off.
both 0.
Off.
We
Both
don't-
off.
We're done with
Okay.
Yes.
this route.
Then both
So
off.
it should be the switch. It's with the reverse
Yeah,
of this.
Then it will work exactly as a.
So this is this one. I'm thinking negation.
That's 0, 0.
So this is 0, 0,
So what does it look like?
0, 1.
Toggle it?
Yeah, that's fine. No,
So-
it's not gonna
It
toggle.
won't toggle?
Yeah, so try it.
So is that am I hitting the
Okay.
pulse?
Yeah.
Yeah, see, it's not toggle
Okay, so
because it's working as set or reset.
Reset. So
Set
0,
and
1.
reset, yeah.
Then
And then the other way, if you
then I
zero,
should make it. So this would be 0, 1.
on the S and C and the G and K. Or
So
the
this
G.
becomes 1, 0.
It
Will
just
it toggle
depends
or
on the
no?
other one.
It doesn't toggle.
Yeah.
1, 0. And then now switch those two.
This is
Alright,
the S and
0,
C.
1.
Hit the pulse. Still 0, 1.
Yeah.
Perfect.
It's basically set and
Then
reset,
at 1, 1.
and now they're gonna toggle. No, you still have them as 1, 1 is not allowed. Remember, that's the error state. That's
So now we're
correct.
back to here, not
Yeah,
allowed.
yeah, that's the error.
I
state.
thought the point was JK would solve the 1, 1 issue.
It
though.
solves the 1, 1 if you have
So
not on the SC.
nothing toggles in this.
not on the SC.
In this one, nothing toggles. In
This did.
No. I mean, on this
Oh,
half,
yeah, yeah.
nothing toggled. Is that good?
Well, let's see. When you have them as 0, 0 here like this, when you have in this state,
Mhm.
when you have S and C are 0, 0s, then the JK solves the problem. So JK solves the problem of having J and K as one.
Okay.
So if you put those in the off state, the S and C, those are off like this or on?
They're on like
They are on. So make them like this.
Yeah.
Now it's gonna toggle. So now J and K are one. No, J and K are one.
Yeah.
Okay, now it's gonna toggle.
Yeah.
See now.
Yes.
Okay, makes sense.
Yeah.
So that's the only difference between the other.
So on this half, so when J and equals to K equals to 0, nothing should toggle.
when J and
In
K-
this half, should it toggle for any of
no,
the
it is like this. When J and K are equal to 0,
It
then
cannot toggle.
No, then now you toggle if S and C are zeros. So J and K equal to 1.
No, I mean when they're equals to 0.
Then it's
yeah.
RS flip flop.
So nothing toggles. Okay,
Nothing toggles,
RS
nothing
flip
toggles,
flops.
Nothing toggles, yeah. So RS flip flop, it does not require the clock. See, it's like this. RS flip flop, you remember, does not require the clock. RS flip flop is just set or reset. So it does not really require any toggling or anything.
So
So if you look at the
why is 0, 1? Well, I guess it makes sense because it's given the same
yeah, it's just opposite if it's
once. Well, yeah.
Which one?
At this
Which
point.
row? Which row? Which row?
So I don't know. I don't even know my question.
It's. I mean, you can search it more. Probably. Yeah. But that seems to be working as expected. Means the JK toggles only if you have J and K are on.
So this is meant to be an RS flip flop.
It's an RS flip flop with a extra.
So
switch
if
features. Yes,
if-
it's like this. Let me explain to
so-
you one thing. You see, RS flip flop was the first flip flop ever they built, right? So what it did, it has set and reset. Only.
yes, so why it shouldn't be switching? It should have the same. Why is it the opposite of this? Shouldn't it have the same value here?
You mean where?
RS flip. It should have the same value as the inputs, if I'm not
Well,
mistaken.
it's like this. You have the JK flip flop, which is an advancement of the RS. So you can go back to the RS flip flop, and you can go to the JK flip flop.
So JK does okay, yeah, that was in the assignment. JK does the opposite.
JK does the opposite, but it does more. So this
Yes.
is JK that you
So
have.
this JK will give the opposite of the, because if it's RS, whatever you get in the inputs is what you get in the output.
Yeah. So
But with JK switches,
not really switch.
does the
JK
opposite.
Yeah, no, well, it's like this. JK can work as an RS flip flop.
Yes.
And can work as JK flip flop.
So in this case,
In which case you have to go from here.
in this case here,
Yeah.
why if it acts as an RS flip flop,
Okay.
0 1 should not give 1 0.
No, 0 1 and 1 0 will act as a flip flop. Now remember, this 0 1 and 1 0, this means reset, and those are the configuration of the flip flop.
Yes.
This is the P and the R.
So which
Yeah, it's okay. Let's take it slowly. This S and R, those are the configuration of the flip flop that you can put it in the JK mode or non-JK mode.
okay, my question is okay, so is this correct?
Yeah, it's working as expected. I don't see a problem, but let's understand it first. So S and C, those are the configuration of the flip flop. What the flip flop are we talking about? The JK flip flop. This JK flip flop can work as an RS flip flop under some mode, or it can work as a JK flip flop under some mode, right? So the fact that you put S and C in the proper state, you expect from the flip flop to work in that state. So if you look at the description of the S and C, so they have more description in there. So one of them will force it in a certain state, and the other one will force it in the opposite state. I meant to put the data sheet, but let's go back to the lecture one more time.
This?
Yeah, no, the one above. Yeah. So this flip flop, you can see it has PR and CR. So CLR means you force it in a certain state. So you can force it in the clear state, or you can force it in the preset state.
Oh, never mind, it's correct.
So you can force it to be in some state.
Because I know that in S, I know that for SR, for most of them, whatever is in the input is the output.
So that's when you have the set.
But in this case, they're both negated. So that's why it's the opposite.
Right.
So
Right. That plus, the RS flip flop, it sets. So when you set S to whatever you want, then it gives the output as 1.
Yeah.
And when you set the R as 1, then it will
because that's why I was confused. Because even if it's setting and resetting, it was still meant to have the same value in the input.
That's why they.
But because it's opposite, so it makes sense now. Yeah.
Yeah. So this chip, this IC has the feature of JK flip flop and the RS flip flop with more advanced features, such as the RPC.
Do you get it?
Yeah.
As long as you get the toggling of calling, which is the whole idea of this lab, and the JK equal to 1, which could never exist before. Yeah. So JK flip flop came to fix the problem of the RS flip flop. So RS flip flop was the easiest one, and then JK flip flop came and fixed the easiest. And there is also the T, that's T flip flop. That's also a flip flop by itself, without dealing at all with the S and the R. So S and the R was the first flip flop to build. And then after that, they solved the problem by JK flip flop, and then JK flip flop was fine, but then they also implement the T. If you look for the T flip flop, all it does is just stop T.
Imagine if someone asks you, "What did you achieve in this lab today?" You just do.
All of them are like that, right? All of the labs are like this.
Yeah.
In digital logic, all you do is just flip the switches, right?
So this goes.
So that's mainly what we do in the digital logic lab. We just flip the switches and toggle LEDs.
You just be like toggle.
Yeah, LEDs.
Toggle.
Toggle is mainly what we do achieve.
Okay,
That's the only
let me take a picture of this.
Yeah, that's the only new thing in this flip flop. It's just the fact that toggles.
Mhm.
And then after that, they implement the T flip-flop, which also doubles without worrying about the RM. Now, if you look fundamentally, as our flip-flop is the first flip-flop ever that was mainly built of the gates, of the two gates with the feedback. And flip-flops, as we mentioned, they will not exist just by themselves. Usually they exist as part of the system.
I guess we can switch this off.
Yeah. And we can put it in the card.
Yeah.
So next time.
God bless the person that found it.
Yeah. Cool.
I said, God bless the person that found the box.
Yeah, those helps at this point, but we also
Imagine doing this with the, like building it from.
with the
Well, would it have made a difference though?
It would have made testing slower,
Yes.
and it might have made
Yeah, like Paul said.
troubleshooting harder.
Yeah,
It
because the
would have
switches-
checked all of our switches.
Agree. And the switch and the LEDs are powered in a permanent way.
Yes.
You don't have to worry about provided to switch plus and minus. Those are provided already underneath. Yes, right? Yeah, I knew we had them, but so we continue something.
Yeah, we have to disconnect. Whew. This was a successful one. Thank you guys.
The counter lab will be much better with this one because in the counter lab we'll use the 7 segment and we'll also